Hi everyone, this is Xiaolong, and here's the report of the model training used in topic modeling and word embedding on Wikipedia data, especially for living people's data in Wikipedia. So what's the difference between these two models? The topic modeling was based on the documents as context. The word embedding used words as a context. This difference captures different types of semantic similarity. The document-based capture semantic relatedness. In other words, the bold and the water. The word-based model captures semantic similarity, the bold and the shape. So that's the difference between the two models. And I want to build a system using both of the benefit of the semantic similarity. So for first, I trained the topic modeling. I choose different number of topics, 2, 3, 4, 5, 6. And as you can see here, when you search, use two topics. The left one include play music and film album is all about the artists, like the musicians. It also includes the athlete, like the season, game, league, football, and so it combines two topics. Obviously, the right one also have elect president, and the party of these politicians, and it also includes the research, the professor, science institute. So this is all about the scientists. So we will see if we increase the topics, it would help us to have a better result. So if we use 3 topics, we can find the artist was alone. The politician and scientist was steered together, and the athlete was also apart from the artist. So it works. And if we add one more topic, this time it will have 4 topics: one for politicians, one for scientists, one for athlete, one for artists. So it works well. However, if we increase one more topic, we find the artists right now have 2 topics. So you can see film, music, and in here we also see the music. So the music appear twice in different topics, and maybe there are some difference. Like this artist 2 was a musician, and artist 1 was a part of the artist, but it is unclear because we can see the music was shared by both of the topic. So after then, if we increase one more topic, we can find the artist was 2, and this one is mostly about the music, album, film, and this one was mostly about the writer, published book. So there might be some topic beneath the artist topic, and also we can find the athlete is also divided in 2. The first one is the championship race, Olympics, something like the competition, and the second one is the ball game. So it's like play, season, football, basketball, baseball, something like this. So there might be some topic beneath the athlete and artist, but here I will use the 4 topics modeling to build the software in the project. So after then, I'll show you some topic distribution of the topic modeling. If I use the 4 topics modeling, if you search for some of the topic of each document, like the order of topic is politician, scientist, athlete, and artist. So, for example, if I choose ID equals 1, the Alfred J. Lowy, he was a scientist because he has the second one, the scientist has the highest weight. So he was basically a scientist. And also, if you choose the 1000, the Karen Nether was the athlete because he has a higher weight in the third one, the athlete. So that's how I build the model, and how it works in the topic modeling. I will use this result in my software in the project. So that's all about the topic modeling. I would use, however, most of them are correct, but some of them are incorrect. For example, if you choose the ID equals 1, the Digaboo Moreau, he was an athlete, as he used to be an athlete and now is a teacher on campus. He would have 2 columns higher than 0.25, but both of them are not significant large. So in this case, I won't choose the max as the way to pick the topics for a person. I will use the higher than 0.25. So if a person have more than 2 topics, I would tag both of them. So that's how I build the system. After then, I will talk about word embedding. The word embedding was used the word to give you the semantic similarity. Well, we can find it here using the word embedding based on the data trend. By the way, I use MetaPy word I use a Meta toolkit word embedding instead of the TensorFlow to train the model of word to vec. However, I didn't update that in the proposal, the project proposal. However, I use it in the end. So we can play with the data if we say I use the sister minus woman plus the man. You'll find it will return the result of brother. So that's how the word to vec use. It use the word as a context to do this, to find the similarity. Also, if you choose the Michelle and Obama, and you plus them together, divide by woman and plus the man, you'll find the Barack Obama would show in here. So that's how it works in word embedding. You treat each word as a vector, and you use the vectors, use the cosine similarity to find the relationship between 2 vectors. So here's just an example of how you can play with these models. However, I didn't use this. I didn't use that in the final software. It's hard to let people select the right words to do the interaction or to do the plus and minus. So I didn't use that in the software. So here are some examples of the word to vec for the Barack Obama. When you search for the Barack Obama, it will show some people like the Clinton, Bush, Reagan, Ronald, Carter, Michelle, Romney, Hillary. So all of the people are highly related to Barack Obama. And also other words like the president election, inauguration, administration, presidential, senator, secede, FDA, so other topics or words related to Barack Obama. So it looks great in the Barack Obama example. It also worked for the previous, like sister minus woman plus man. So overall, the model was good. However, it doesn't work in other names like the Pablo Picasso. The word related to Pablo Picasso is Neruda, Montoya. So most of these people have a name Pablo, Neruda, John Pablo Montoya. So here I want to show that word2vec has some problem when you have other people have the same name. The Barack Obama works well because both the Barack and Obama is not the common words. However, we can find when the Pablo was a common word, the Pablo Picasso will recommend useless word like the word with other Pablo related to the other Pablo, or just the non-related words. Some of the words might be related, like the Plato, Métis. These are the artists or related to Pablo Picasso, but others, most of them are non-related. So we can easily find the result is bad in this situation. I tried different solutions for this problem. First, replace all the names as one word, such as use Pablo Picasso, replace the white space between them, and make it one word instead of two words. However, other documents might also use Pablo or Picasso, refer to Pablo Picasso. It will be hard to get all the reference updates, so you need to update or cleaning all the documents contain the Pablo Picasso. So it's mainly impossible if I do it manually. Another solution is try to use other word embedding algorithms such as Doc2vec. It also treats the whole document as a word and do the word embedding. However, this time even the Barack Obama won't give a correct result. So I tried the Doc2vec, use the Geniums. It was really useless. It didn't give a correct result. So that's all about the model training report, and thanks for listening.